Hi to all. So in this video, we're going to solve this two-step binomial tree, and we will do this for a call option, right? So what do we do when we have the two-step binomial tree? How can we solve it? Well, let's look at this and let's work step by step. The first thing is that in this case, we are given U and we are given D and we are given the stock price today, but we are not given the stock price at the following nodes. So we need to calculate those ourselves using U, relying on U and D. But as of this point, this should be straightforward because we know that the stock price here in node B, so in the good state of the world for the stock, is simply going to be the stock price today multiplied by U. Next, the stock price, if we continue to the next step of the tree, and we can once again there is another good event, or the stock price continues moving up, then we can get the price of the stock at node D by multiplying this node B by 1.5. So now we have those values. Conversely, if the stock price moves down after so if we have a price of $50 for the stock today, and then the stock price moves down, then we can get that price exactly by just multiplying this $50 by down, so 0.5. And then let's assume that the stock price continues moving down, so we just need to multiply this by 0.5 again. And there we go, it keeps going down to 12.5. Now, in this case of node E, we can get it in two different ways. We would get to the same value. We either multiply this 75 in node D, in node B by down. So we multiply this by 0.5. And it is as if once the stock goes up to 75, then it comes back down to 37.5. But we can also calculate this as 25 multiplied by 1.5. So it is as if the stock price went down to 25, then it goes up to 35, 37.5. Either way works. Now, the next step, once we have this, what we have done is we have completed the tree for the stock, and now we need to complete the tree for the option. So the way we do this is we start by the final nodes of this tree, and in this final nodes we are basically looking or evaluating the option price at expiration. So in this point we just use the formula we already know, which is max of stock price, and we have the stock price right here minus strike price or zero. Then in the following node, we evaluate it in the same way. So it's max of stock price, which we have here, minus strike price or zero. And in the final node, we use the same formula, and it is stock price minus strike price or zero. Now, we can get those last nodes of the tree using this intrinsic value formula, but when because the intrinsic value is exactly the price of a call option the day of expiration, right? But we need to find the possible values now before expiration. So we need to solve for nodes B and C. And how can we do that? We can then use the formula for the price of a call option here, the one we had used before already, we have used before in the one step binomial tree. So basically we need the probabilities, and we need the probability of the call option going up in price multiplied by this price of the call option if it goes up, then plus the probability that the call option moves down or the stock price moves down, multiplied by the call option price in that bad state of the world, and then we just get the present value of that. So since we need the probabilities, let's start with the probabilities. So what are the probabilities? Probabilities, keep in mind the formula is, once again, we have used it several times, is 1 plus r minus d. Then we include all of this in a parenthesis, and then we divide this by up minus down. And there we go. This is the probability that stock will move up. Now, an interesting feature about the binomial tree is that this is going to be the probability if we're evaluating this nodes of the tree. Probability that the stock price will move up is 0.55. But if we're evaluating this portion of the tree, that probability is still the same. And if we're evaluating this portion of the tree, the probabilities are still the same. So the probabilities are the same in every one of the nodes of the tree. That's a feature of the binomial tree. And of course, if 0.55 is the probability that the stock price will move up, 1 minus 0.55, which is now 0.45, that is the probability that the stock price will move down. So now it's simple. Here we just use the formula, which is probability that the price will go up, or the price of a stock moves up, multiplied by the price of the call option in this good state of the world, plus probability 1 minus b that the stock price instead would move down, multiplied by the call option price in that bad state of the world. Finally, we just close all of this in parentheses and we divide this by 1 plus 0.5. And what we're doing by dividing by 1.05 once again is we're just getting the present value. Now we have node B. And interestingly, if you're using Excel, you could simply do Control C, copy, and then Control V here. And you would very likely get these results, except that we need to, we need to lock the cells before we can do this. So we could do this. We need to lock the cells B8 and we need to lock the cell B9. So these are the probabilities. We want those references. We don't want those references to change. And then we want this risk-free rate also locked. And now we could do this. However, let's just do it manually. So we would have the probability the price will go up multiplied by the call option in this good state of the world, plus probability that the stock price will go down multiplied by the call option in this bad state of the world. Then we close all of this in a parenthesis and then we just divide it by 1 plus the rate. Once again, what we're doing is we're bringing it to present value. Each step of the tree may not be a full year. So this at 5%, we may need to adjust if we're looking at a tree in which each one of the steps is 3 months, for instance. However, for simplicity within the scope of our class, we're just going to assume that this 5% risk-free rate is just the holding period. This is a holding period rate. So this is the relevant rate we are supposed to use. We're assuming that for simplicity. So now we have calculated the price of the call option in nodes B and C, and we can move forward to the calculation of the call option in node A. And the way to do this is we multiply by probability of price of the stock moving up multiplied by the call option in that good state of the world plus the probability that instead the stock price moves down, multiply by the price of the call option in that bad state of the world. Then we close all of this in a parenthesis, and once again, as always, we divide by 1 plus the rate. So we're getting the present value of that, and that is it. This is our call option price is 22.39. And if we want to write the solutions, at node D we have this price, at node E we have this price, at node F we have this price, at node B we have this price, at node C we have this price, and then finally at node A we have reached the price of our call option. Okay, so we have finally concluded the two-step binomial tree for a call option, and this is exactly how we are supposed to get the final price for this call option, which is what we get in node A right here. Okay, so I hope this is helpful. Thank you for your attention.